there's a box that hides a square, a triangle, and a circle. I want to pick a square, but I can't see, hear, or feel the objects. What are the chances? This is called probability. It shows the chances of a desired event to happen depending on the circumstance. Probability always yields in between 0 and 1, never more, never less. We have the simplest example that can be done at home: coin flip. You can take only one coin and toss it in the air to see which side it lands on. It lands either on heads, tails, none other. Maybe the edge of the coin, but that is an extremely rare case. We can break it down with both cases. Ignoring the coin edge, both heads and tails chances combine to be 100%, as the cases always happen in every toss. So each case has 50% chance to land facing up. Let's take another example with an object that results in equal chance, a fair dice. One dice has increasing value of 1 to 6 pips on each face. When we toss the dice in the air, it lands one face facing upwards. The chance of the desirable number of pips is 1/6. We can show these chances with a visualization of a cube. But are these the only objects that predict chances? Randomness always reoccurs when no pattern is happening. Random noise image and audio sampling, weather prediction, even choices made by your mind are random. Many factors come into play for a chance of an event to happen. We only take faces of the polyhedron as a factor of chance. Therefore, I wonder if those objects can behold the same value 2 times in a row. Spoiler, they can. Probability can be divided into 2, unconditional and conditional. The unconditional probability can be divided into 3, independent, mutually exclusive, and not necessarily mutually exclusive. The probability of independent events never happens simultaneously, but the chances are multiplied. We can visualize the chances of independent events using pathways. Let's say I want to roll a 12 in one roll of 2 dice. One dice must land a 6 face up, then it lands a 6 again on another dice. Therefore, each value has 6 branches as pathways for the value of the second dice, making 36 pathways. Landing 6 twice in a row only leads to one pathway, so the result is 1 in 36 pathways. Moving on to the mutually exclusive events. Chances for both events happening in mutually exclusive events are always 0, thus meaning both chances will never happen at the same time. In coin flipping, you cannot get heads and tails at the same time. In dices, you cannot get different number of pips at the same time. Let's use a deck of cards this time. I want to draw one black suited card or one diamond. The chance of drawing one specific card happening is... There are 26 black suited cards and 13 diamonds in one single deck. We can't get a black suited card and a diamond at the same time, since they don't share the same property. Mutually exclusive events are denoted as this formula. A union B means the combined chances of event A and event B. And A intersection B means the property both A and B have in common. We write event A as the black suited card and event B as diamonds. Since A and B share no common property, the probability is 0. The third one is the not necessarily mutually exclusive events. The only difference is both events A and B share one common property. We can take the previous example using the cards. Let's say I want to draw a black suited card or a king. There are two cards which shares those properties, which are King of Clubs and King of Spades. The formula can be written like this. Same as mutually exclusive events, we have two separate chances of black cards drawn or kings drawn. But black cards that are kings are possible. Therefore, we subtract the chances of black cards drawn and the chances of kings drawn by the chances of black cards that are also kings drawn. The chance is This means that out of 13 cards, 7 of them will be black suit or kings. Of course, this wouldn't happen in your first try of drawing the cards, but the frequency of the calculated chance happening will increase the more trials you do. That means if you draw 13 cards multiple times, the number of black cards or kings will get closer to 7 compared to any number. It happens because it follows normal distribution. More of that in upcoming video. I've been emphasizing two keywords so far in this video, or and. These two keywords are very important as it gives us a choice of picking an element over trial, and they are the key to remember the combined chances of events. If it's or, then it's the combination of the chances minus the chance of common property in two or more events. If it's and, then it's only the chance of common property in the events. Let's switch to the conditional probability. This applies that event A is a chance from the result of event B, vice versa. Using the previous example, I want to draw a single black suited card, and I also want to know the chance of it being a black suited king. Therefore, the first condition is to find out whether the card is black suited, and we denote this as event B. We already set the boundaries of the kings drawn to be black suited, so we denote this as event A. This is read as event A given event B. The formula is the chance of event A, which is the card being black suited and a king, narrowed by event B, which is the chance of black suited cards drawn. That means out of 13 black cards that has been drawn, there's a chance that one of them is a black suited kings. Another probability is the inverse probability, which is the other chance that is out of the desirable one. The probability and the inverse of it must equal to 1. We look back at the probability of the black suited kings, and the chances of black suited cards that are not kings is. There we have it, a short essay of probability. It is useful when you are predicting the common chance of what events are happening, picking the better choice, and leading to a better outcome. Next video, we're talking about axioms of probability and the normal distribution.